Hey, hello everyone. I'm Alpay Sabuncuoglu. I'm a research associate at the Alan Turing Institute. Unfortunately, I couldn't attend in person, but my co-author in this paper and in this research, Karsten, is there. And if you want to learn more details about this research, you can email me or talk to Karsten in person. And it's the early findings of our research on large language models and its impact on digital foundational identity and more generalizable, maybe on digital public infrastructures. So let me start with identity. Identity is a complex and multi structured concept. So when we integrate large language models, we can find many potential applications. And when developing a digital identity system, it's actually essential to understand the usability, security, and privacy, also maintainability aspects of the development process. And over the maybe past 2 decades, we've seen some integration of technologies like web, cloud services, or biometric services, or blockchain uh, integrated in these ID-based services. And with the improvements in the security, privacy, and usability, these technologies have become integral to these modern digital identity infrastructures. And in this environment, we start by categorizing the technologies, how they integrated into these modern infrastructures. And we found out that we can classify it into three. And these are core technologies, supportive mechanisms, and innovation accelerators. So it's just a classification to ease understanding the overall process. So when we integrate large language models, like which technology stack can we integrate into? And in the core technologies, we have database services, authentication and management structures, front-end services, and communication protocols. So these are essential systems that can help the building overall structure and maintain it in a good way. And we have supportive mechanisms like biometric technologies, which improve security and usability of users. So these are supportive mechanisms to enable core technologies work smoothly. And we also have innovation accelerators such as blockchain and generative AI. So when we try to integrate these innovation accelerators, it can help the infrastructure leapfrog in the field. And also all these mechanisms can be move to different categories like machine learning. For example, when we say machine learning, we can use it for fraud detection, but also we can use it in biometric technologies. So all computer vision solutions are part of actual machine learning techniques, but it can also be innovation accelerator. And also a brief intro to large language models. So they are advanced AI systems, and they are trained on a large amount of data to understand and generate human-like text output. So they can perform a variety of tasks. It can be translation, summarization, or answering questions. And we saw that this chart is from Our World in Data, and it's an open website. You can see lots of data interpreted. And in this chart, we saw that in the last 5 to 8 years, the large language models outperform the humans in many tasks. And we can see that it's a very recent progress. And unlike handwriting recognition or speech recognition, since it's very new, we are identifying the risks and also safety issues newly. So we still have time to investigate these technologies. So what are the possible use cases in the ID domain? And when we start this research, we first thematically analyze the main challenges of the onboarding process in the Africa context. So these challenges are specifically analyzed for identifying issues in onboarding process. And we focused on ID for the diagnostic reports. It provides comprehensive and country-specific assessments, and we focused on African countries, so 17 reports in 17 countries. And one key challenge is the concept of identification, which can sometimes become a source of conflict, so it can be a political issue. And another challenge is existing laws and regulations may fail to cover all relevant issues and leave gaps that can hinder the effective implementation and operation of the systems. And the third challenge is reliance on physical centers for the registration and maintenance of ID records. And this can create some logistical challenges in maybe remote or disadvantaged areas. And the fourth one is limited ability to serving communities with restricted traveling abilities. So these are four challenges, and large language models can be used as an opportunity to resolve these challenges. So we can use them for insight generation or systematic knowledge creation. So for example, you can analyze both government regulatory documents and also Twitter feeds to identify if there is a conflict and like in public opinion. So we can resolve this issue before occurring, and we can enhance the inclusivity with multimodal large language models. And also by combining with OCR, optical character recognition technologies, we can accelerate the digitalization of the records. And in all the process, so these challenges are focused on onboarding processes, but we have authentication and authorization steps too, and we can use large language models to reduce costs in all steps. Of course, there are some also risks of integrating LLMs, so we also categorize them into three. There are data-related risks, and also model complexity related risks, and social behaviors and human values risks. So for example, if we want to integrate large language models, right now the most popular approach is using trained models released by Microsoft or Google or like any other company's model, which has access to high performance computing resources. And when they train their models, they introduce some biases. It can be historical biases. So it's based on data source, and also it's based on algorithm. So bias is a huge issue, and it can cause some fairness concerns. Also, if you want to use large language models in a complex business logic, it can cause some privacy concerns. So for example, if you want to integrate in two different operational silos, and if they are communicating with each other, it can cause some privacy issues. And also when you integrate these models, and if you need to explain the decision, so let's say for credit scoring, and if you want to explain this decision, it can be hard to explain from a large language model perspective. So it's not sometimes interpretable. And of course, there are some concerns on safety, especially human value alignment, or it can cause some toxic linguistic And here we can see large language model development flow. It's from OWASP's top 10 LLM attack strategies report. So, but it's a good way to analyze what can be the potential issues in large language model development. So, it's focused on security perspective. So, let's say from app services to data services, it can cause some sensitive information disclosure or insecure output handling. But it also helps us to structurally analyze fairness, also privacy issues. And here you can see third-party vendors and open versus closed models all can be discussed while integrating large language models in digital public infrastructure systems. And in our research, our next step will be a more systematic analysis, especially focusing on fairness, privacy, and security concerns. Right now, we are working on creating a both cookbook and also some executable notebooks so practitioners can integrate large language models in a more fair, private, and secure way. So it will be our next step in the research. And finally, large language models have the potential to transform DPS, and we need to critically analyze potential security, privacy, and fairness instance because it has actually huge potential, but it also brings lots of risks. So we need to move carefully, and also integrating large language models can bring risks from historical bias to inability to track issues in complex business logic. So we need to structurally progress and conduct risk analysis while integrating large language models. Thank you.
Right.